I have triangle ABC, and I have triangle DEF. Okay, so in this picture, we're going to be answering these two questions, and they have to go in this order. So question number 1. Are these triangles congruent? Yes or no? I hear a yes. Anyone else want to chime in? Yes. Yes. Okay. Why are they congruent if you think they are? So you guys are saying yes. Why? Angle, side, angle. We have two angles with the side in the middle. Okay. So now, we know they're congruent because you just said they were by angle, side, angle. So is angle E congruent to angle E?
Yeah.
Is angle B congruent to angle E?
Yes.
Why? Yes, because they are corresponding parts of congruent triangles, so they are congruent. What about AB congruent to DE? Why? Because they are now corresponding parts of congruent triangles, so they are congruent. Okay, what about EF and BC? Are they congruent? Yes. Why? Because they are now corresponding parts of congruent triangles, so they are congruent. So once you're able to answer yes to question 1, those other 3 fall into place. If we hadn't answered yes to question number 1, we would not have been able to answer question number 2. Okay? That's the whole behind the scenes idea with our proofs for today. We're starting by showing that triangles are congruent, so that way we can, in fact, say that all these other pieces are congruent. Okay? So, our first picture that we're going to draw. Draw a V. Then we're going to draw a vertical line going up from our point. And then we're going to connect each of the endpoints of the V with the endpoint of the vertical line. That doesn't quite look symmetrical, but oh well. And I'm going to label it STOP. And we're going to be given SP is congruent to OP and angle SPT is congruent to angle OPT. And our goal is to prove that angle S is congruent to angle O. So I'm gonna make a note to the side. Unlike yesterday, we're not showing triangles are congruent and stopping. That's what we did yesterday. But we do have to show that two triangles are congruent first. Okay, so we are starting them the same way, even though that isn't our end goal. We need to show that two triangles are congruent before we can show S and O are congruent. So, who can tell me our first statement for any proof? The given. So, as we write the given, because my picture is not marked, I'm going to also mark the picture. So, SPT, that's this angle here, is congruent to OPT, this one here. I also know that SP is congruent to OP. All of that was given. Can we say that the triangles are congruent yet? No, we're missing some information. So, is there anything else based on the picture that we can say? Okay, why does PT equal PT? Reflexive property. And we want to make sure we say congruent. So PT is congruent to PT by the reflexive property. So then I can make my marking there. Do I have enough information now to say that the triangles are congruent? You think so? Which postulate would we use if we had enough information? Side angle side, because we have two sides and an angle in the middle. Two sides and an angle in the middle. So I'll have side angle side. So let's see, STP, and I need to make sure I'm lining up corresponding parts here. So S would go with O, and then we'd have T with T and P with P. Okay, so now that we know they're congruent, what can we say about S and O? So we know they're congruent, so now that means that S and O are corresponding parts of congruent triangles, and they are congruent. So we can write that final step using our corresponding parts from earlier. So how we got to step 3, that was what you guys worked on over the weekend, last week. Today we're just adding that one extra step to say something about another piece of the triangle. Okay, any questions so far? Okay, let's go to another one. So I'm going to turn my page here. Okay, so with this picture, to draw this one, I'm going to start with an upwards diagonal. Kind of go over a little bit so I have a space, and then I'm going to do a downward diagonal. And then I'm going to take the bottom of the first line that I drew and connect it to the top of the second, and then from the top of the first to the bottom of the second. So we have these two triangles. So just like the ones before, we want to start by showing that the two triangles are congruent. Because once we know they're congruent, then we can say all of the corresponding parts are also congruent. So what's the first thing that we write in all of our proofs? The given. So as we write the given, we're going to also mark the picture because our picture is currently not marked. So YT is congruent to YP. Angle C is congruent to angle R. And angle T is congruent to angle P. All of that was given. So again, we're starting with trying to say whether or not these triangles are congruent. That's what we need to do first. Do we have enough information to say these triangles are congruent? I hear some people whispering no. Anyone think we do?
Yeah.
What do we have?
Angle, side angle, for the vertical angle.
Okay, well, if we're gonna do vertical angles, we have to state that, so we wouldn't have enough information yet. Okay, so yes, we can do vertical angles. So is that what you were thinking too, Analea? So if we use our vertical angles here, we would say CYT. So angle CYT is congruent to angle RYP by vertical angles. And so now we do have angle, side, angle. So we can say that triangle CYT is congruent to triangle RYP. So once the triangles are congruent, what do we know about CT and RP? So CT and RP are now corresponding parts of congruent triangles. So they are congruent. So we can state CT is congruent to RP. Does anyone see how we might have been able to do that in 3 steps instead of 4? Because we actually could have done that in 3. What was that? We had angle, angle, side just from the given. So if we didn't do this vertical angle, we would have angle, 2 angles, and a side not in between. So we didn't have to say that vertical angle piece, but it's not wrong to do it. And the reason I wanted to point that out, especially on this example, is when it comes to your tests and quizzes, we're going to give you more lines than you may need, so that if you do end up taking a different route than what we do, you have enough lines to do so. So on a quiz or a test, you may not use every line we give you, but that's because we're going to give you the most amount of lines you might need, but there might be a shorter way to do it if you see something different. Okay, so could we have done this in 3? Yes. Is it wrong to do it in 4? No. Okay. All right, how are we doing so far? Okay? Good? Bad? Just okay? Just okay? A lot of okays? All right. So this next part that I want to do one more proof with you guys, but before we do it, we need to practice looking for triangles. And what I mean by that, I'm going to start by drawing a line, a horizontal line, and then from either end draw a short vertical line. Almost like you're going to draw a rectangle, but don't connect them. Take the ends and go diagonal. how many triangles do you see in that picture? Just think about it right now. Just think right now. How many triangles do you see in that picture? Now, just by, on one hand, show me how many you see. Okay, so I see 3s and 5s. All right, can anyone tell me one of them that you see? Yes, sir.
in the center.
Okay, so you're seeing this one right here.
Yeah.
Okay, anyone see a different one? N, M, all the way to P, so you have that big one there. What's another one? Angel? N, P, Q, or N, Q, P, so the other big one. Okay, any others that you see? P, Q, and then that middle one? Okay, what's the fifth one? The N, P, and then this middle one. Okay, so you could see 5. I only care that you see a specific 2. Okay? The 2 that I want you guys to be able to notice are the 2 that are overlapping. So if you think of this, think of the bigger triangles. So N, M, P, and P, Q, N. Do you see how we could separate those 2 triangles? That's what I want to do, is practice drawing and separating the 2 bigger triangles that we see. So the first one is N, M, P. So N, M, P. The second triangle is this bigger one, P, Q, N. Okay, how many of you guys saw these 2 triangles in that picture? Okay, how many of you just saw the little ones? Okay, if all you saw were the little ones, that's fine. But when we talk about this unit, you're always looking for the bigger triangles. So think more of the outside shaped triangles. What are the big ones? Because what we're going to be doing is we're going to be doing proofs with what's called overlapping triangles. And one of the things we have to do is separate them. So we're not going to be separating little triangles, we're separating the big ones from each other. Okay? So when we separate the big ones here, so these 2 triangles, do they share any information? So if we look back at the original, okay, they share NP. So even though we've separated them, what did they share in this picture?
N and P.
They shared that whole side. So that means in our proof, we would be able to say that NP is congruent to itself by the reflexive property. And this is something that when we have overlapping figures, we're going to look for what was that piece that overlapped, what line or what angle did they share, and then we'll be able to use reflexive property for that, even though we've drawn them separate. Okay? We're going to try another figure and see again, look for the bigger triangles, and then we're going to separate them. So this one, how many of you guys ever watched Star Trek? Okay, looks like this next one we're drawing looks like the Star Trek symbol. So start with an upward arrow looking, or an upside down V, however you want to think about it. Go down about 1/4 of the way on either side and make a mark. And then we're going to connect the end point with the marks opposite of it. So it kind of looks like a Star Trek symbol.
What's the Star Trek symbol?
That.
Oh.
If you don't watch Star Trek, you wouldn't know, but usually there's always a few people that watch Star Trek who know what it is. Okay, so A, D, B, E, C, and that's it. So again, we're looking for the 2 bigger triangles. So yes, you might see some smaller ones. We want the big ones. William? Say that one more time. AEB. So we have this big one here, AEB. So if I draw that over here, BEA. Okay, anyone see the other one? Dima? CDB. Okay, that's a C, not an E. Okay, so in looking at the original picture, just like in the one before, how they shared that side but we separated it, what did these two share that we separated? Angle B, which means in our proof, we would be able to say that angle B is congruent to angle B by the reflexive property. Okay, whenever you have overlapping triangles, this is what you're going to need to do. Separate them and identify what's that reflexive piece. Is it an angle or is it a side? Okay, so how are we doing with the overlapping so far?
Perfect.
Okay, so let's do our last proof, which is going to actually be a picture that looks a lot like this one, but a little flatter. So this is our third example. So I'm going to start with my V. And this time, instead of only going about a quarter of the way, I'm actually going to go about halfway, so that it makes it a little bit flatter of triangles. And I have A, B, C, D, E, F. And we'll be given AC is congruent to EC, and CB is congruent to CD. And our goal is to prove that angle A is congruent to angle E. So, to start off, we would want to separate the two triangles. Figure out what are the two bigger triangles that we need to separate. So the first one that I see we need to separate is CBE. So E, C, and B. The other one that I see we need to separate is CDA. So CDA. What was the part that they shared before separating? Angle C. So they both shared that whole angle C. Okay, I need to remember that for like step 2 of our proof, because step 1 is our given. So for step 1, and I'm going to use my separated pictures to mark on, mainly because when we start marking on an overlapping picture, things start to get a little confusing. So AC is congruent to EC. So AC, EC. CB is congruent to CD. Let's see, CD, CB. That's our given. Now step 2, what was the overlapping piece? Angle C. Because C was the angle that overlapped and is shared in both of them. So I can say angle C is congruent to itself. Sorry, my handwriting's getting really messy. Angle C is congruent to angle C by the reflexive property. Now, in looking at the two separated triangles, do we have enough information to say they're congruent? Okay, which postulate? Side angle side. So we can say that triangle ACD is congruent to triangle ECB by side angle side. So now that the two triangles are congruent, we can say angle A is congruent to angle E because they are corresponding parts of congruent triangles and they are congruent.